Quarter 2 Project Leaf Blower Chair Spin Experiment by Mark Maloro, Aidan Tagg, and Sean Thornton. Essential question. We are asking, how does positioning affect periodic motion? Hypothesis. Our hypothesis we stated is that the sitting down position will have the fastest rotation, followed by sitting upside down, then standing on knees due to the differences of the amplitudes.
What is our project exactly? Our Quarter 2 project consists of Mark spinning in an office chair that is being propelled by 215 mile per hour, 510 CFM, 58.2 cc gas backpack blower with tube throttle. Using 3 different positions, we will determine how periodic motion is changed. The positions we will use on the office chair will be sitting down, sitting upside down, and standing on your knees.
The components of this project include the amplitude, which is the distance from the leaf blower to the camera, the period, which is the time of one rotation, the midline, which is the distance from the middle of the chair to the camera, and the frequency of motion, which is the amount of rotations in a given amount of time, or rotations per second.
Video 1 explanation of Mark sitting in an office chair while sitting down. The amplitude is equal to 4 feet. The period, which is 2 pi over b, equals 2 pi over 1.55 seconds, equals 4.05. The midline is 20 feet. The frequency of motion is 0.247 hertz, which is the opposite of the period, which would be b over 2 pi, and in that case it would be 1.55 seconds over 2 pi, and that's how we got 0.247 hertz. Our equation for this video is y equals 20 plus 4 sine parentheses 1.55x parentheses.
Video 2 explanation of Mark sitting in the office chair upside down. The amplitude is 2.5 feet. The period is 2 pi over b, which is 2 pi over 2.4 seconds, and that turns out to be 2.62. The midline is 20 feet, and the frequency of motion is 0.382 hertz, which is the opposite of pi, which would be b over 2 pi, so 2.4 seconds over 2 pi, which again turns out to be 0.382 hertz. The equation is y equals 20 plus 2.5 sine, and in parentheses 2.4x.
For this video, the amplitude is 2.82 feet, the period is 2 pi over b, which is 2 pi over 2.23 seconds, which equals 2.62. The midline equals 20 feet. The frequency of motion is 0.355 hertz, and the equation is y equals 20 plus 3 sine, parentheses, 2.23x, parentheses.
Here is all three different equations, again from the different positions, shown on one graph. As you can see, red, which is the sitting down position, has the highest amplitude being 4. This goes up to 24 and down to 16. This is followed by the green line, which represents standing on knees, with an amplitude of 3 going up to 23 and down to 17. Last, with the smallest amplitude of 2.5, the upside down position equation goes up to 22.5 and down to 17.5. The periods in order of largest to smallest is red, green, and then blue. The farther the leaf blower is held from the center of the chair, the faster you will go, meaning less time per cycle. At the beginning of the graph, starting at 0, they all start together because they start at the same time, but due to quicker cycles or periods as time goes on, the equations start to separate and sort of mix up near the end. The highest frequency is blue, green, and then red.
Conclusion. After collecting the data of all three videos of sitting in the office chair, we found that the higher the amplitude, the longer the periods. That means the longer the period means lower frequency. So in conclusion, we found that the sitting down position recorded to be the fastest rotation. Then it was followed by standing on knees, and finally sitting upside down.
Simple versus damp motion. Simple motion is a type of motion where the restoring force of an object is directly proportional to the object's displacement from a certain point, or the amplitude remains the same. Damp motion is a type of periodic motion in which energy dissipating force acts, typically caused by friction, or amplitude becomes smaller over time. Our project is an example of simple harmonic motion because the amplitude remains the same during each video. Major responsibility for this project was creating the iMovie, which includes doing the research for the project, such as the project components and the simple and damped harmonic motion. I also created the slide topics and inserted information such as the graphs as on Desmos. I also helped to assign and complete the voiceover roles.
For the second quarter project, I believe my contribution to the group was more mathematical and organization. I feel I helped the group create our equations and find the different components of the equations, and also felt like I organized our group and made a plan for us to get things done and how to do them, and that's it.
For the second quarter project, I felt that my most contribution to the group with this project was making the videos for our project. So I got our leaf blower, and then I had my dad's office chair, and I went out and recorded the videos so we could make our assumptions and our equations for this project.